Hi, in this video we're going to talk about evaluating piecewise functions. So a piecewise function is a function that has a different definition and different intervals of its domain. And you have to be very careful when you do it because some mistakes that are made is when students substitute values into the wrong expression. So if you look at this function, f of x equals, so that means that when it's going to be 2x minus 3 when x is less than 4, and then it's going to be x squared minus 2x when x is greater than 4. So that means when x is going to be less than 4, we're going to use the first equation. And when x is greater than or equal to 4, we're going to use this equation. So this is how it works. Remember, when you evaluate a function, you're only going to get one value of the function for a particular value of x. You cannot get multiple, and what that means, you cannot just take whatever number is given to you and substitute it into the first expression and the second one and come up with two answers. So we're going to work with this function that I just used as an example, evaluating f of 1. So where is 1? Is 1 less than 4 or is 1 greater than or equal to 4? Clearly 1 is less than 4. So that means our value of 1 is going to be substituted into the first equation. So 2 times 1 minus 3, which is going to give us negative 1. 4. You have to be very careful when you're on that boundary point. Where does it equal? So 4. Is 4 less than 4? No. Is 4 greater than or equal to 4? Yes. So we're going to use the second equation. So it's going to be 4 squared minus 2 times 4, which is going to give us 8. F of 6. Is 6 less than 4? No. 6 greater than or equal to 4? Yes. So we're going to use this one, the second one again. 6 squared minus 2 times 6. And that's going to give us 24. Okay, next example. So we're given this function here, and that's how it's defined, and we're going to do the same thing. So starting with negative 3, where is negative 3? The first equation or the second equation? Well, negative 3 falls on the interval when negative 3 is less than or equal to negative 1. So we're going to use the first equation. So the absolute value of negative 3 minus 2 is going to give us 5. Where is negative 1? Well, in this case, negative 1 is going to be in the first equation because negative 1 is less than or equal to negative 1. It does not belong here. So the first equation is going to be negative 1 minus 2, absolute value, which is going to be 3. F of 2. Well, 2 is greater than negative 1, so we use the second equation. It's going to be 4 minus 2 squared, which is going to be 0. This next function, negative 1. Negative 1 is less than 2, so the first equation, so negative 1 plus 5 will give us 6. 2. The first one or the second one? First, second, the second, because it's greater than or equal to 2, equal to. So it's going to be 5 times 2 minus 3, which is going to give us 7. And 4. 4 is clearly greater than 2, so belongs also in the second equation. So 5 times 4 minus 3, which will give us 17. And we have one last example. So this one has a function that is defined with 3 different expressions on 3 different intervals. It is possible you can have functions defined with more than 2. So do you do anything different? Absolutely not. Still have to figure out the interval where a particular value belongs and substitute that value into the correct expression. Negative 3. Negative 3 is going to be less than or equal to negative 1. So it's going to be 1 minus negative 3, which will be 4. We use the first equation. Negative 1. Well, negative 1 is still here because it's greater than, less than or equal to negative 1. So you're still substituting that there. So it's going to be 1 minus negative 1, which will be 2. 1. Well, 1 is between -1 and 2, right? So we are going to substitute that value into the second equation. So the absolute value of 2 times 1 plus 1, which is going to give us, my apologies, let me rewrite that, it doesn't look good. 2 times 1 plus 1, and that's going to equal 3. 5, where is 5? No, I'm sorry, 2. So 2 is still with the first one because less than or equal to 2 is here, so equal to is going to be there. So 2 times 2 plus 1, absolute value, that's going to give us 5. And finally 4. Well, 4, where is 4? 4 is greater than 2, so the last equation, in the last equation there is no value of x, it's going to be constant, so the value is automatically 3. Okay, and that's how it's done.